LeetCode Problem 199, Binary Tree Right Side View. So this problem gives us a binary tree, and we have to basically return a list of nodes that appears on the right side only, right? So for a binary tree like this, 1, 2, 3, 5, 4, we will need to return 1, 3, and 4, right? If, for example, there isn't this node, then we will have to return 1, 3, and 5, right? Because it's the most right node, right? Okay, alright. So the way I approach this problem is to use a DFS, depth first search method, where we are searching through from the right, from the left, no, from the right first. But technically it doesn't matter where we start from. So in this case, I start from the right side and then on the left side. And while I traverse, when we reach a certain level that our size is lower than the certain level, I will need to push in that current node. Okay, I'll explain more on how that works, but let's see, I have a vector here and a DFS. So this DFS will take in the root. It's currently where we're at, 0, which is the current level, we're at level 0, and then a vector, right? So once we have that done here, since this is a recursive method, I am checking if the root is null. This is my exit point. This is how I will exit this function, and I'll just return. Okay, otherwise I will do the rest. Okay, let's see. So for the vector, I'm going to put all the way up here because this vector is using a reference. So whatever changes we make into our vector, it will reflect over here, which is what we are going to return. Our root, using this as an example, we have 1. Our level is 0, right? Okay. Then we check if our vector size, which is currently 0, and 0 is less than 0 plus 1, right? So 0 is less than 0 plus 1. So that means this is true. That means we have to push back the root value. So pushing back 1. After that, we DFS to the left side. So I'm going to do like this, equals to, so our root is, right side is 3, level is now 1, and then we check again, right? So in this case, our vector size is now 1, and 1 is less than level plus 1, which is 1 plus 1, which is 2. So that means we push back the one on the right. Okay, the one on the right, which is 3. Okay, means we push back our root value, which is 3. After that, we DFS on the right side again. So right equals to like this, root is equals to 4, level is equals to 2, right over here, level plus 1. And then we compare again. In this case, since 2 is less than 3, we push back 4. Okay, and then we DFS again. Right is equals to, okay, here when we DFS one more time, we have reached null. Alright, so when we reach null, this will return. That means our right has returned. So I'm just gonna close it up. I'll just leave it there. Okay. Close it up. On our left, we also have to return because there's nothing on our left. So this left and right, I'm just gonna do like this. Okay, so we close it all up. This right is done. And then our left, right? Because here we are to recurse left as well. But since left there's nothing here, so left is closed up. So this is done all the way to here. Okay, and our root node. So now we're back at 1, and we traverse on the left side now. Right. So our left side, our root becomes 2, level becomes 1, and now we check. Right. So currently our vector size is 3, and 3 is more than 2. Right. 1 plus 1 is 2. 3 is more than 2, so we don't need to push back. And then we DFS on the right side, and right side is now. Right side is 5 actually. So right side is 5, so root is equals to 5, level is equals to 2, and 2 is still less than level is 2 plus 1, 3 is still less than level plus 1, so 3 is, this is false basically, because 3 is not less than 3. So we don't need to push back. We DFS to the right. The right is null. Right is null over here. Null. Left is null. So left and right closes. Right? Both of these are nulls. So this right will close. Now we iterate on the left. And on the left is also null over here. Null. So this closes as well. Then once that happens, our left closes. So we return here. We return over here. It means DFS has finished recursing. And then we return our vector, which is 1, 3, and 4. Sorry, 1, 3, and 4. Okay, so now let's imagine there is no 4 here. Right, let's imagine there's no 4 here. And then let's try again. Let's see what happens. Let's see how this DFS method will work. Okay, again, vector, empty vector. The root is 1. Once again, level is 0. And then we check first. In this case, our vector size 0 is less than level plus 1. Right, 0 is less than 1. So we push 1. After that, we DFS on the right side. So right is equals to over here. So root is equals to 3. So now we're over here. Right, we have entered down here. Over 3. Level is now 1. We check again. Vector size is 1. 1 is less than 1 plus 1. So we push back 3. Okay, then we DFS right again. So we're moving to the right side. And in this case, now right is pointing to null. Right, remember just now I said we are trying out if there's no 4 there, so right now right is pointing to null. Left is also pointing to null. Right, there's no node here. So this will exit. Then we are back at the root. Now we are going to the left side. Okay, when we are on the left side, root is 2, level is 1, right over here, and then we check. Right, so vector size is 2, is smaller than level plus 1, so 2 is smaller than 1 plus 1. If not, so we don't do anything, and then we go to the right. We try going to the right again. Right, so right, in this case there is a node, right, 5. So root is 5, level is now 2, and when we compare, since our vector size is still 2, but now our level is 2 plus 1, and in this case 2 is smaller than 3, so we push back the value 5. Okay, then we go to the right node again, left node again, right? So right node nothing, left node nothing, and we come, and this is done. So again, we go to the left node, so there's nothing here. So left is also done. We exit here, exit, DFS is done. We returned 1, 3, and 5. And if you noticed, oops, 1, 3, and 5 are the right side, right? Where this is not here. They are the most right node in this binary tree. Okay, so I'll repeat again. This if statement, we check the vector size and the current level we're in, right? And if we're at a level where there should be a node, and if there isn't, that means we have to add one from the left branch, right? So that means this DFS, it must start from the right side, right? I think just now I said that it can be any side, but in this case, it must be on the right side because we are doing the right side view, right? So we are checking whether or not there are nodes on the right side first. If there are, that means vector size should be more than or equals to our current level. If there are nodes, that means our left side node should be longer than our right side node. And when that happens, we have to push the nodes from the left side into the vector for us to return. Okay, slightly misunderstanding there. That's all I have to share. Thanks.